And the title of our panel is Redefining the Production in Defense Industry. And I would like to invite Mrs. Sadullah Uzun, General Director of Milli Technology and AI. And now I would like to invite our panelists to the floor. Tiberius Aerospace co-partner and strategic director, Andy Baines. Next speaker is a scientist, ASFAT General Director, Professor Dr. Mustafa İlbaş. Welcome. And our next panelist is General Director of TUSAŞ Engine Industry, Professor Dr. Mahmut Faruk Akşit. Now, I would like to give the floor to our distinguished participants. Thank you very much. One of our panelists is coming from abroad. We have been talking with each other in order to decide on which would be the language of this panel, and we decided to talk in Turkish. Distinguished participants, welcome all. And of course, it's very exciting, and there's a lot of excitement here in the Saft Fair. But I would like to make also a short commercial now, with your allowance. So I am the General Director of Milli Technology, National Technology of the Ministry of Science and Technology. It's a very new era, and we are going to be talking also about production in the software as well. Of course, AI is a very important part of it, as we do all know. And with a very important step taken, our General Directorate's name has changed, and we added also artificial intelligence as well. So we have a very big scope of duties that we're going to deal with AI, and we are going to be preparing an action plan for Turkey on what artificial intelligence can be done in the future. So we are going to make the launching of it in the near future. And today, early in the morning, we were in a very important launch. $750 million is going to be mobilized. We have actually announced it for incentives. And Andy is coming from this area, from entrepreneurship, and where he's going to understand it very well during his time of entrepreneurship. We are going to ask questions about what he has done during his period when he was an entrepreneur. Yes, we started talking about AI, but we are going to be talking about sustainability, products, and also artificial intelligence. We are going to be debating about these matters with these three very valuable colleagues of ours. They all have different perspectives, and they're going to bring up different visions. Andy has worked in Apple, Google, and Nest, and then has entered to defense industry. And we would like to learn about why he changed the sector. And Professor Dr. Mustafa İlbaş, on the other hand, he is the General Director of ASFAT. He is an academician, and the academic culture and his experiences in ASFAT is going to make a good blend of our debate. And Professor Dr. Mahmut Akşit, and for about a decade, he's been working as a general director, as an old entrepreneur. I was very much inspired by his life story, and I'm very happy to moderate all of you. And I would like to begin the panel, and I'm going to ask two questions. We are going to separate into two as round one and round two. I think for each question, we can give 10 minutes. First and foremost, let's start with Andy. And this is how we are going to continue later as well. Dear Andy, Tiberius is actually has a mode of defense service. Is actually dealing with a more actually is working on the consumption area as a model right now. And what type of actually can that be conveyed to the countries that want to also develop themselves with such defense strategies? And what can Turkey do about that?
Well, thank you for the kind introduction. So yes, I am reasonably new to defence. We launched Tiberius about 2 years ago, and what we decided to do was take a model, commercial model, that we used at Apple and that I see in companies like NVIDIA, so very sort of hyper-growth companies. And that model is one where we do the design and development in our case in the US, but then we license our design for manufacturing in countries like Turkey, Germany, UK, Poland, and so on. This model of federating the manufacturing is called defense as a service. It's what we call this today. Why is it important? It's important because, as you all know, there's a heightened concern among NATO nations to develop their own capability on their own terms, rather than being dependent on the US or another single sovereign nation. The second is that if you are going to build long-term resilience in weapons and other capabilities like electronic warfare, you can't maintain speed and capability depth with a single monolithic prime system. You have to have a very broad network of manufacturers competing on price, performance, and capability into a design. It's exactly how we built the iPhone in 2007. It's how the entire consumer electronics industry transitioned in the late 90s. So a lot of you in the room are much younger than me, but I'm old enough to remember that in the late 1990s, nearly every consumer electronics manufacturer owned their own manufacturing sites. By 2002, they'd sold everything, right? So Hewlett-Packard, Dell, Samsung, LG, Sony, all these major companies got rid of their own manufacturing sites. And they did that because they needed to focus on speed of design, which in engineering terms we call that continuous iteration, continuous development. And that was how they were going to develop a speed advantage, as well as bringing your performance of your products up whilst bringing the cost down. So why did I come into defense? Defense is the only, so I've been part of very disruptive journeys during Apple, Nest, and Google. At Apple, the first major disruption was the music industry when we launched iTunes and the iPod. And what we saw was a similar sort of stuck model where a 20-year-old commercial and innovation model had not gone through any innovation. And we needed to upgrade that, and we thought we had an important mission to do at Apple. I see exactly the same problem in defense. What I see in defense is very slow-moving development of very expensive systems that are unable to accelerate in time of war and are unable to lower cost in times of peace, right? And that is the model we've been stuck in for the best part of the last 70 years. So we at Tiberius, we've developed two weapons. They are liquid fuel ramjet ballistic missiles, and we've developed a software platform to enable this speed and this federation of suppliers. We also believe Turkey has an incredibly important role in the future of NATO's strength, for three reasons. As I look around the world, and I'm going to finish my answer here, but as I look around the world, as a designer, as an engineer, there are three things that I care about. Is the country hosting a large customer? That's point one. So Turkish MOD. Can I test my weapons here? That's a really important point. So if you look at the SpaceX model and how Elon has been so successful, he's able to iterate a design, get immediately back on a test site, fire that design, collect the data, go back, redesign, go on the test site again. That fast iteration is absolutely critical. Our weapons have a range of 200 kilometers. We need a big country to do the testing in. Turkey is literally the only country that has the real estate to do this kind of testing. And then the third is, does the country have a heritage in large-scale precision manufacturing, right? Turkey has all three of these. It is a critically important nation for us going forward. Thank you.
As we still have some time, can you hear me?
Yeah.
Hello. Sesim tamam şimdi geliyor. As we I just want to listen your story how you transferred from entrepreneurship world to the defense industry. You said why, but I'm asking how.
Yeah. Oh. Yeah. So it's I'll tell you the short version of the story. So. We sold Nest to Google in 2014, and immediately after selling Nest, we were finding ourselves in a slightly difficult situation with a very strong competitor, which actually was a Ukrainian company called Ring. Ring then got bought by Amazon, which you probably all heard about Ring. So I was very intrigued about this. I flew out to Ukraine. I loved what I saw there. What I saw was effectively another Silicon Valley at the early stages. This is 2015, 2016. I ended up buying a company in Ukraine, growing that to about 400 engineers. And then, of course, the Russian invasion started. And that forced me into defense. That was the moment when I was mostly disappointed at the West's response to Ukraine. I started to analyze why was it that we weren't sending proper capability to help these people who are defending, the Western world. And what I saw was essentially a capability gap. What I saw was hyper-exquisite systems, so hypersonic and supersonic missiles that cost between $1 million and $4 million, shooting low-cost Shahed drones out of the sky. And then I saw munitions, and there was nothing in the middle. There was no capability in the middle that was low-cost, scalable, and not exquisite. So that seemed to me like an obvious starting point for me to start another company, and that gave birth to Tiberius. Yeah.
Teşekkür ediyorum. Şimdi tabii geçmişte
Thank you very much. Yes, in the past, Andy experienced before Apple, Nest, and Google, and as an entrepreneur, as an old entrepreneur, he is someone that I really follow closely. And before the panel, when we were talking to each other, I was one of the first people who bought Nest. And when I was going to the United States, I bought it. And then when I turned back to Turkey, I couldn't use it because it was specific to United States. But the packaging itself, even sold itself, it was really amazing. And then with the Failing book, you explained the background of it. We always talk about dual use in the defense industry and the technologies that develop there kind of evolve into civilian technologies. But in your case, it is kind of the reverse version of that. And you are actually conveying the experience to the defense sector. So thank you very much for your answer. Now I'm going back to Aspat with Mustafa İlbaş. Aspat with some 27 military factories and shipyards, 10 shipyards. You are in the manufacturing part of this, and when you look at it from the software perspective, what kind of a process do we need to make sure that we have a transformation in this area? Thank you very much for the panelists being here and for the participants being here. As the general manager of ASPAT, I salute you all with respect. When we talk about the defense industry, we talk about a huge ecosystem. And of course, it is a constantly developing and changing sector. And everything can be momentary here. And when we are doing Saha Expo here, maybe at the same time, our friends are developing new systems. It is such a fast-paced process, and new technologies emerging in a very fast pace. But the sustainability of it is the most important thing, because it is the most valuable thing in the defense industry. Just like you said, ASFAT is 100% state company. We have military factories, 27 of them, and 10 shipyards. We are using their the opportunities that they are providing for us, and of course we are working on them to modernize for the MRO activities. We are using these factories and shipyards, and it is an old system actually, but in this system, in this ever-changing era, we have to consider the software, which is one of our topics today. Manufacturing based on software becomes an important issue. So what can we do from this perspective? I come from academia, from university. I have a past in the academia for 40 years, and I'm also an engineer, and I am also interested in the defense sector. And of course, there's an advantage to being an engineer in this area. It is a sector that we closely follow up. And, you know, we are always thinking, what can we contribute to this area, and what can we do by placing the software in the middle of it. ASPAT is a company of 8 years, but the factories and the shipyards have hundreds of years of history. So when we think of this huge heritage and this big structure, we need to bring it to the software. We need to adapt it to the software era, or this new era. So we have undergone this process of restructuring ourselves, because we had to make sure that we adapt. And technology was in the forefront, and engineering was in the forefront. So that's why we have established some directors and also some structures that support these areas for the transformation, such as digital transformation and the manufacturing with the focus on software. And in order to follow new technologies, emerging technologies, we put great importance on IT and also R&D works. So that was the basis of our structural change. And this production, dark production, or production based on software, is not just about the production itself or manufacturing itself. It is also a key part in the sustainability of the defense sector. It's not just depending on the manufacturing. Yes, you can create or you can manufacture many platforms, but you have to keep them ready. You have to maintain them. Maintenance, and especially timely maintenance, is really important for the sustainability of your work. And it is really important to keep being able to work on them and keep being able to use them. And defense systems, you don't use them on a regular day, you know, even if they are for defense. You have to use them in a case of war or in a case of conflict. You have to make sure that they are not out of use. You have to maintain them really, really in a great way. And sometimes you even have some technologies or some weaponry that you cannot use before you need them, you have to keep them in function. And for the Turkish defense industry, in all platforms, we have our infrastructure for the air, for the naval, for the ground, and modernization of these infrastructure is possible thanks to the work that we all do, and not just in a single city. With the factories in all the coastlines, for example, we have the ability and the infrastructure to build new shipyards, and this is the capability of our country, and we are supporting this capability with increasing our capacity with Aselsan, Roketsan, Baykar. They create platforms, they develop platforms, and we are focusing on how the MRO is done on these platforms, how the maintenance can be done on these platforms, and other platforms that we acquire from other countries in order to make sure that they are sustainable. We pay importance to the maintenance again, and to make sure that we develop new capabilities, and we have to keep them ready for defense. This is one of our main goals. And with these factories and shipyards, we are not only doing the maintenance work, but we also do the manufacturing. And especially in the shipyards that we have, all classes of ships, thanks to these ships, ASFA, in the previous year, in the export of defense industry, we were the champions in the naval side. So on the naval side, we started from the smaller boats to 10, 12 meter long boats, and open sea ships, and also E-class or our own project ships, for example. We have done a lot of things, and we didn't see that as something that's sufficient for us. Again, we have TF or TF 2000. We are now working on that, and our national submarines as well. We are the main contractors for that. And this can be the small summary of what we are doing in these shipyards. But we are not just working on the keeping the software in the focus. I just wanted to reiterate that we want to keep software in the core in these modernization processes, and also in order to improve the efficiency and the energy management, you have to keep the software in focus, and that's why we have created the infrastructure for that. And with the works that we are that are underway, we will continue to do so in the future. As a moderator, I feel really lucky. You are really keeping good track of time, and you finish even before your time limit. So this is really excellent. Thank you for allowing me to be a great moderator. And I think it's because you are all entrepreneurs, so that's a good way of using time. In the notes that I'm taking, there are some key words that you mentioned. Sustainability is one of them, and when you are doing this, you mentioned the dark factories or dark manufacturing. You use that word. It is actually in digital transformation we use this term a lot, and as our general directorate, we are working on the digital transformation and creating awareness, raising awareness on this topic. And also there are some leading programs that could contribute to this transformation. Of course, we cannot go without talking about AI. Embodied AI or physical AI is also another part that is used in the manufacturing, or the machinery that is used in the manufacturing is made more effective through the use of AI. Thank you very much for touching upon these keywords, especially. Now I want to move forward with Mr. Mahmut. We talked about your resume. Of course, in TE, you have 17 years of experience, and in abroad you have an excellent level of experience, and you combine these experiences from around the world. and you are doing a great work in the country. We talk about manufacturing of engines. It is a hardware-focused sector. So when you try to look from the software perspective, what can you say about your work in TEI? Well, when we talk about engine, it is a mechanical structure, right? You know, everyone thinks about that part first. And, you know, where does software come in? Software is everywhere. You know, you have to have it in the design, starting with the design, manufacturing, the assembly, testing, and then the life cycle of the product. You have to think about this whole process, and at every step, I cannot even tell you how important software becomes. I will try to summarize what I'm going to say. Starting from the beginning, even at the beginning of the design level, even before you draw anything, before you transform anything into model, we cannot do anything without software. And when we talk about software, a lot of young engineers, they tend to think that the international market, professional softwares, they think of that first. But they are already existent and they have to be in our lives. But can you design an engine just by using them? No, it's difficult to do that. A real engineering company using their own designs, this type of platform cannot be sufficient for them. And one of the first departments that I started in my company was the engine design tools department. And their task was to design, analyze, and the basic software. They were actually responsible for creating the basic software that would help the engineers and the designers to design the engines. And now our unique engine design codes reached, I believe, 100. And these pertain to, you know, when you first you come face to face with the client and they say, I want this type of engine, I want the range to be this much, and I want this temperature at this altitude, it should be this level of power, etc. You collect this like data set from the client, and then first the thermodynamic cycle is designed, and also the analysis part becomes really important. So you need an analysis tool. So that's where the engineering, detailed engineering softwares or platforms for stress analysis, for example, it's something that you can use. But for other works, you need specific softwares. Now you collect the data and then you enter them, and then you ask them, you know, if this is like two-level engine, what can I do, and what is the efficiency, what is the velocity, etc., what is the fuel consumption. You have to go forward and back, and to do this in a fast-paced manner, you need this unique software. For structural part, of course, if you determine the levels, the velocity that the engine must turn in, you have to do the blast analysis for the discs, for example. You have to consider the cycle, the load, what material you have to use. So these design tools, or the design tool team, let's say, they create these softwares. Just like when you go into the App Store on your phone, we have for our engineers, when they go into our site, they can see 70, 80 different applications, you know. So depending on what work they are going to do, they can actually select from these software. So the coding actually is done by us. So these are from coming from the basic engineering principles. We created these softwares. After all this is done, then the general carcass of the engine is determined, and then you go into details. If I put this hole here, what would be the stress there? Then the smaller fine-tuning or the fine details come into play. So you have to have a software that is related to that. You cannot do anything without the software, so we took care of that as well. In the past, of course, we were using different types of calculations, but you can see from all around the world, we used to use the equations that came from other countries, other places around the world. They can use that still. They can create an engine with that. But now, at this level that we are at, we are putting software in every level of engineering. We are trying to approach our design to a perfect level, near perfect level. After the design is then done and completed, then you build a prototype, and then you try to see if you can get this performance out of the engine. In the past, when the project was being planned, you would probably see maybe 5 cycles of design. But when we first start working on it, after our software became more mature, even in the first design cycle, you can get the design that you want. And the first prototype that you produce gives you the performance that you intended. And this is the main contribution of the software. It gives you an immense contribution in terms of the speed and the design. And PD 175 engine, for example, it's our first engine that we created from start to finish. Everyone is increasing to 130 feet. We went to 45,000 feet, We produced our model, we did everything from start to finish, and we pushed the engine, and we made it. And there are the Murphy rules, when something can go wrong, it goes wrong. And just like that, we were kind of scared, because it was, in our minds, it would say that, this must be a coincidence, because in the first try, if you do something, we were always thinking that it will go wrong somewhere. But we actually were aiming for 175 horsepower, for example, in the first engine that we tried. And with the high quality of the software and our designs, we have reached that level immediately with our first try. So you cover almost like 10 years of development or 10 years of changes with just one software and the infrastructure of great engineers. And we are decreasing the cycles or the design cycles, etc. For the PD 175, for example, I don't know how many prototypes we would have tried, but with the first try, we actually managed to do that.
So the engineering is completed, but while we are manufacturing, we have to actually make the software as well. So you have to do it all at once. As you know, there are CNC, computer control numeric. These are the machines. And we are doing it with all these machines. Everything is coded. Before coding it, the engineer has made a 3D dimension design. We have the technical pictures, and before going to the manufacturer, we have also extra engineers who are using all new softwares. And from a log as a raw material until its end, until it's finishing, they are modeling each process, and we are doing it in such a sensitive way that there are some certain pieces that takes a week to be actually processed. So when we talk about aviation, of course, you need to be very sensitive, and I am working on very micro parts. And you have to write the code in such a way that 3D, they are also, you are programming all of the cutter edges of the device that you're using. So as you are passing through, well, when you, after a certain amount of time, of course, it wears out. We are actually measuring also how much it wears out. So even if it's a micron, and we have to determine all of these calculations, of course, and then we start our manufacturing. I would like to give an example to Gökbey. When we made the first design, and the first round of the design, we have completed it in 2.5 years. We're going to, well, we talked, of course, we need to get into the details of the design, but it seems likely to be that the engine is working. And I started and I said that we have to put this through manufacturing, but they said to me, we have to work on details, it's not yet complete. I said that you can work it, but I'm going to actually manufacture it, I said. And I said, I take all the responsibility. And later on, they confessed that, together with my vice general director, nobody believed that the engine was working except of me. The engine really worked. And I'm an engineer as well, and I have received that presentation of that engine, and I understood that it's going to work. Okay, we're going to make the manufacturing of this. And I said that I have the responsibility, I have the budget. If there's something that is not working, then you have to come to me, and I'll take the whole responsibility. We went to the manufacturing engineer. So, the first prototype took 3 years to be completed. And I said that, what are you doing? And the engineering completed it. You say that you can only complete it in 3 years, but they told me that we are going to make all the we are going to try it, we are going to see whether the sensor code is working well. So we are going to use new parts, and we are going to change parts, etc. There are thousands of parts, of course. For each part, 3 years is even less than normal, they said. So what are we going to do? Of course, we cannot work on paper. We worked on the computer models. We used the software, every part of the software, and we optimized everything. Just a year later, our engine worked. Because of the excellency of the software. Of course, we are buying software as well, but we have also macro patches that our engineers have developed. These are very much important indeed. We are giving rewards each year to our staff, to our manufacturers. And some of our engineers are making such an actually software macro that just one single engineer's success or improvement, we earned millions of dollars a year. So software is everywhere in the world right now, in every part of life. And the mechanical STEM, how important the software is, just ask me. I'm so sorry. I have, so you already actually completed your words with that the software is everywhere in our life. But as I was listening to you, in each part you have integrated the software. So you have that vision, of course. And thank you very much. And it also changed the way I'm of manufacturing the engines. A competitive engine is very much important, isn't it? Yes, I have to reiterate it. Okay. Dear Andy, now we come for the second round. So you were talking about entrepreneurship, and I wanted to ask about your experiences. And throughout your career in Apple, Google, and Nest, you were making updates almost every week, and you are coming from a world where update has to be constantly done. And when you implement this ideal to the defense systems, and thinking about the export restrictions, certificate licensing, licensing, etc., in all of these cases, how would you actually bundle this whole up? Because I try to combine the sector that you were working in and this sector again, how you are handling everything at once.
Yeah, okay. So I think, first of all, in order to achieve the kind of speed that we were doing at Silicon Valley and translate that into a weapon, like a 155 millimeter ramjet missile, two things have to be true. The first thing is the weapon needs to be open architecture. So in the case of our design, we have designed it from the ground up to allow other third-party systems to be versioned into our missile. So those third-party systems might be a seeker system, might be an IMU, it might be a thermal battery. In our design, everything is a threaded screw interface. There isn't a single weld. There isn't a single, standard bolt screw. So it is designed from the outset to be open architecture. That is a critical point to maintaining speed. And why is that? It's because we're still a small company. I have 30 engineers in Tucson, Arizona. And even if I had 300 or 3,000 engineers, we would still be too small to have a capability that can take on an adversary, right? To take on a nation state. So then what you're left with is a fairly simple question and answer, which is, how do I maintain speed, or Silicon Valley speed, so 3-month upgrades to hardware, when I've only got 30 engineers? And the answer to that is, I use everyone else's engineers, right? So I have an open architecture, and I allow other people's systems to be versioned into my system to improve its performance and maintain lethality at the highest level. So that's really the main thing. And then the second thing that needs to be true is you need to have enough other companies available to you competing with each other on price and performance. And those other companies right now are too small. They're measured in defense. The ones that are certified to operate in defense are measured in the low thousands. If we are serious about winning the next war, we've got to increase that by a factor of 10, if not by a factor of 100, which means we've got to take all of the companies that are currently not engaged in defense, and we've got to bring them over and have them engaged in defense, right? And they've got to start versioning their capabilities into open architecture models, whether it's a drone, whether it's a USV, whether it's a missile, whether it's a tank. All of those now need to be upgradable. Thank you.
Şimdi bu round,
So this round is a little bit more personal. And I wanted to also ask you, what is the Milli Technology? Have you heard about the National Technology Initiative? Have you ever heard about it? National.
Turkish initiative? Yes, I have heard of it. Yeah, so that's right. And by the way, I hear this labeled different ways in different nations. I mean, Germany's doing a very big push on national, initiatives. But as I mentioned in my previous answer, I think Turkey is going to be playing an extremely important role in the future.
Şimdi bunu özellikle sordum.
I asked this question. Well, you gave also the example of Germany for the national initiative movement. Actually, the technology, it is actually the brand of the technology strategy. Each country has to actually create a strategy so that they become a technological country that can, and Germany does it as Industry 2.0. And for Turkey, this is our movement. Maybe I had to actually explain it a little bit because so that you can actually really understand. Tiberius can we get a little bit about the information about the activities that Tiberius is doing in Turkey?
Well, so at the moment we are looking for our first manufacturing partner here. We are, that's partly why I'm at this event, so having those conversations this week.
The stage is yours then.
That's one part of it. The second part of it is bringing as many Turkish OEMs into our software platform, which we call Grail. It's the marketplace. So then every other MOD in NATO, JEF nations, as well as Indo-Pac, can now start to see Turkish capability in this marketplace. We have created, to your point about the software, we're using about 1 million hours of compute every month, creating these simulations which compare one company's capability with another company's capability against real-world vectors. Those vectors could be electronic warfare, could be hardened targets, could be environmental conditions, different weather conditions, different personnel conditions on the ground. And that allows MODs to compare the capability of a Turkish-built level 1 drone with a Ukrainian-built level 1 drone with a US-built level 1 drone, all in real time at no cost to the OEM manufacturer, which is, I think, the point that you were making. So now, if we're serious, and I mean this sincerely, if we collectively in this room are serious about winning the next war, we cannot rely on the traditional prime model to do it. It just won't succeed. It's not fast enough, it's not cheap enough, it's not open enough, right? And we know this because we can see what's happening to systems like Excalibur in Ukraine. You know, it took best part of 10 years to develop it. It costs about $100,000 to $200,000, and within 6 months of it being used in Ukraine, it was redundant, couldn't be used. The Russians had figured out a way to jam it. And now, you know, for Excalibur to be upgraded, it's going to be another several years. So it's just too slow and it's too expensive, right? And we see this over and over and over again. So if we are serious in this room about winning the next war, we have to find a way to bring so many more innovators, engineers, and young companies into defense. And the only way you're going to do that is if you make it very low cost for them to simulate their designs and do prototyping at a Silicon Valley speed at very, very low risk and very low cost.
Evet, teşekkür ediyorum. Winning the next.
Winning the next war, that's a very important phrase. That's what we try to do here. And as I told you, this tour's question is going to be personal. And we have talked with Andy and how he was working in Apple and started to work in Tiberius. And Mr. Mustafa, so you're working in the academia and also in the defense world, let's say. What do you think that the software and new technologies is going to help us, and how we are going to go further, and how did you actually combine it with your world? And the academia is, of course, we are getting more deeper in research and development in the academia, but on the other hand, we're also producing scientific articles, and there are, of course, all the studies that we are doing there in the academia, the impact is not that strong. The academia takes its time, actually, the time is not restricted or limited. You can complete a research in 10 years, perhaps. But the defense industry is not like that. You have to do it on time. You have to speed up. The timing is very much important. And costs, of course, are very much important. These are the two worlds. These two worlds have to be working together, but on the other hand, are different. And so that we provide them to work together, I decided to work in the other side. Well, because I know these two sides of the coin, it creates certain advantages. In our world, of course, we are making a lot of simulations. We're using softwares and CFDs, etc. And Mr. Mahmoud, the general manager, has already said that, especially simulation is very much important in order to understand how the engine is working, is it working well or not. So it helps us to be very fast. You're very right about that, sir. But on the other hand, when we add up a cost, of course, when you make an experiment for everything, let's say that you are developing a product, and you need to test them, experiment them, and when you testing is very expensive, and sometimes you lose things during the experiment, and the costs are so much. Of course, there's also one other advantage of simulation. It is decreasing the number of tests. So for a product, when you make the simulation of this and advancing with softwares, instead of making 100 tests, you do only 10 tests. So with 10 tests, you can achieve a result. So cost is very much important. And if there is something ignited during your production, that will cost you, for instance, but that doesn't happen when you do it with a simulation, of course. And the cost, as I told you, is reducing a lot. On the other hand, it decreases the time as well. At the university, we did all of these, we made projects, but the implementation area is a sector. So I have so many years of experiences, and I have the opportunity to implement it in the field. And of course, the industry prefers people from the academia because we have been working on these matters for a long period of time. Now in Asphalt we have opened up 28 new units, engineering, technology, research, and especially about the digital part, we have made opened up new branches. On the other hand, I'm also an energy professor, and that's the reason why we opened up the Directorate of Energy as well. Why? Because energy is very much important for sustainability. I have been talking about maintenance and repairs, you can remember, but the second important thing is energy. If you cannot provide the energy safety in the defense industry, we cannot talk about sustainability. And that's the reason why the academia and the defense industry has to be working very closely together, and energy has become very prominent in our establishment, and the studies about that is still ongoing. And there is also another issue here, in repair and maintenance. We have a periodical maintenance, yes, we do know that. But there's also, we can also make predictive maintenance, and we can do it with software. All of the, just before maintaining or before repairment or before any kind of a failure, we are actually taking our measures with these predictive studies. And the platforms continue to work. And with this infrastructure, it can use Their tanks, their planes, which are 60, 70 years old, for instance, can keep it for a long time. If we can actually keep using them for a long period of time, then that means that we are also successful in sustainability. Finally, I can say that due to my academic identity, human resources, of course, is very much important. On the other hand, of course, for sustainability, human resources is necessary. Whatever you do, whatever platform or machine you build up, if you do not have the necessary human resources that can actually reproduce them, or audit them, or manage them, then you cannot call yourself sustainable. So that's the reason why the academia is very much important. I have all, and me and my friends have all the capabilities about this. Working together with the industry, I believe we are also adding up to the human resources as well, because in academia we have trained and graduated a lot of engineers. So whenever we go, wherever I go, I always see my students all around, and I feel very proud about that, because our students, they were students once, but now they're working together with us. It's wonderful. So that's the reason why the human resources shouldn't be only limited with the university, but at least with the universities, with the academia, you can actually continue working with your students in the future as well, in the sector in particular, because it's like a master and apprentice type of relationship. So even though the sector and the academia looks different from each other, they cannot be separated.
So that's why, as the people who know both sides, for the defense industry, we will continue to contribute even more. And I've been here in this position for 1.5 years, and I've been trying to do that. But in Turkey, as Turkey, we are really good in terms of human resources, but there are some issues that we need to think about for the future. You asked Andy about the national technology move. As Turkey, all the friends, all the world is all encompassed in this move. So when we achieve something as a national or local achievement, we will share it with Asia, with the other continents, with Europe. We have this capability and we have this move, but our move will be beneficial for the whole world. Thank you very much for this very valuable insight. And I asked you about the differences of academia and the industry. You gave us some really great insights, but the time difference is really huge in academia and in the industry. And that is imminent, I think. And you also talked about how software impact the costs and also time of production. And we talk about this software part, but you also talk about the after the manufacturing, about the sustainability, and you mentioned the predictive maintenance. This is really something that's a key part, because with the IoT technologies as well, with the one of the sound changes in the mechanical part, even with just one sound, you can actually use the predictive maintenance and take care of the problem before it even occurs. So thank you very much for explaining that to us. So, esteemed General Manager, I will ask you the last question. I'm trying to get a little bit more personal at this stage. In the first question, we talked about the main topic, but I want to ask you, you have a 10-year past in GE, and you came back to Turkey. What was the reason behind this choice that you made, you know? And also for young engineers in this national technology move, what do you recommend the young people in this area? In General Electric's GE, 10 years is not a short time, of course. When I left I was working in component R&D laboratories. I was the team leader there. And the most important thing there is family and a perspective towards life. For me, you know, when I was deciding, I sat down with my wife and, you know, for my children, I wanted them to grow up in our culture. And, you know, the timing was kind of synchronized with my little child starting elementary school. And I didn't want to wait for them to get their education and finish their education in another country. So I have my mother and father here in this country, and they were really pressuring me to come back. And those were important factors. But another important factor is that at the end of the day, we were born here, we grew up here, and we our country contributed to us to come to this level. So this is kind of making me feel like I have this debt towards my country as well. And people who go and live abroad, if they are not thinking in a big scale, they are always thinking like, you know, I will go back to my country someday. But unfortunately, the only time they manage to actually come back to the country is when there are really saddening things like death in the family or something really drastic. So I didn't want to be like that. If you have your health, if you're living, if you're thriving in another country, I think we should pay this debt back so that our next generations actually benefit from what we learned, what we experienced. And when we look at the working conditions of today, for example, younger people, they are working at a very relatively really easier conditions compared to the past, and that's thanks to the people who were working in the past and their struggles. They actually led the way to us having this great environment that we are working in. And you know, in the past we were always thinking like, when you go to another country, you can go there and get experience maybe for 1 year, and then you know, you reach that level of how can I put it, satisfaction for your whatever work you are doing. But everyone was saying to us and to people like me working abroad, you won't make it there, you won't feel comfortable there. But I always thought that you should struggle a little. You should go against your problems, you should face your problems and challenges, and only after you overcome them, you can actually feel that you made it, you succeeded. And when I was coming back here in the R&D section, we were talking about the sealing systems, etc. And I gave a workshop before I started working here about my area. And I had a lot of patents, by the way, maybe 50-40 patents. And I was trying to, in this workshop, talking to people about what we have done so far and what I've learned and experienced so far. And when I was giving this workshop, they told me, you know, we don't have this application area, we don't have this engine here, so we cannot really use this like seal systems on any engine that we have. And then we couldn't collaborate, and then it kind of stuck with me because I have this information, I have this experience in this area. So I was then continuing to teach what I learned, and at the same time I was working on a project with TÜBİTAK, so it kind of coincided. They are working on different processes, and I was working on my area, and it was kind of the beginning of 2000s, maybe 2005, 2006, the time of that project. And it was the first super alloy turbine wing project, and then we used that super alloy in that turbine. And those are for biggest turbines, you know. They are like really big scale turbine wings, and we worked with university students and TÜBİTAK, Material Institute of TÜBİTAK, for example. And now in Ambarlı EUH power plant, these wings are still used there. And when we were doing these things, I think my resume ended up in front of our president, and they were really in need of some jet engines and plane engines. So that's why I didn't have, you know, I didn't have that environment that I had abroad in our country. But then I thought to myself, if we cannot create this environment for other people or for ourselves, we won't have the next generation working on this area. So that's why we started with the infrastructure. We continue to work on it. And now young people come to our company and they are in competition to come work with us. So this is the biggest reward I can get. And we are now applying the all the things that we wanted to have in our country, and all the solutions. Of course, we cannot share everything with the world, or the world doesn't have to share everything with us. But it is really a great motivation to be able to do something that you strive for in your country, and. You know, we have done these projects, so that's how the process all went. Thank you very much. You started your words with the family, and last year was announced as the year of the family, and the president actually with the Ministry of Family. It was a great title for the last year, and you are now giving us a great example of how you put your family in the center of your life, and it's kind of inspiring, you know, and the feeling that you described as feeling indebted to your country. And when I talk about that, it wasn't definitely money. I didn't get any kind of grant or any kind of subsidy from our country. Yeah, but the family culture. Go to Technofest, for example, one student from the first level, the other is from the fourth level, etc. They are talking to each other, you know. They are at different levels of their university education, but they are talking to each other, and they can create this like environment where they can actually interact with each other. And thanks to the projects that you provide, thanks to the opportunities that you provide for these young people, and in the field, they can actually find areas where they can implement the ideas they have. With Technofest, of course, we try to make sure that we include also the investment ecosystem. We introduce them to investment ecosystem and the entrepreneurship. I want to say just one more sentence. This national technology move, the scientific development and young people of Turkey, they get great contributions from that move. And for the last 12, 13 years, I've been working in this position. And now when I look back, the people, the young people who came for applying to our company, we cannot even ask them the same questions. They know everything. They are really, really prepared and ready. Oh, thank you, thank you. This is another great outcome, I think. And now I want to finish with something that I captured from what you said. You have to go against your challenges. You have to face them. So this could be a great message for the young people in this area. I think we have used our time very efficiently. I think we have some time for a couple questions. If there are any questions among our audience, we can get your questions now. If not, then we can finish. If we can get the microphone. Hello. I'm from Karabük University. I'm a faculty member, and I'm work on hydrogen at the moment. And I want to ask you a question about the future of hydrogen. Should we go forward working on this area Do you have any kind of recommendation? You're asking me, right? Yes. So hydrogen, yes, I work on hydrogen as well. It's one of my topics. What was your name? Mesut. Mesut, you probably follow the publishings that we do, but I'm on the burning side of hydrogen, more like composite and as a fuel. And as the industrial hydrogen burning, we have the brewers that are using hydrogen, and we developed it in Turkey as well. But when you think of hydrogen, electrochemical along with thermochemical reactions, it turns into electricity directly. And it is a really important issue in our national submarine project. We will include hydrogen, and a fuel battery will be used. And of course, you have the ability to use the conventional, in the conventional ones. They couldn't do that. They had to surface to get fuel. But with the hydrogen, it will be possible to do it under water. And hydrogen is really all available in the world, but it is not like a natural gas or like petrol. You cannot get it. It is not like coal, so you have to produce it. And when we look at the 130 billion tons of hydrogen, maybe 90% or more than 90% of it is produced with traditional or conventional methods. But also on the electricity side, it is important for the nature. There are some needs for other resources, which are some of the renewable energy sources. So when we look at it from this perspective, the future of hydrogen is an electricity carrier, such as the conventional electricity, but there is not much of a widespread infrastructure for it as of now. So it is kind of lagging behind, but there will be a time, there will come a time where it will be used widespread in a widespread manner. And I think we will be using two energy sources such as electricity as fuel, hydrogen as fuel and as electricity. So I think we should be prepared for it from today to tomorrow. I think it will not go beyond electricity, but we are getting prepared for it as the university. And also maybe there could be another conference just based on defense industry and hydrogen. There's also another question coming. Hello. My question is Mustafa Bey, for Mustafa Bey. Cihan Barut, Havaş, Deputy General Manager. We are number one at steel for 15 years, and 98% of oxygen we are providing for Turkey, and we are giving liquid hydrogen for the Bilgem ships. And as the National Defense Ministry, we are supporting them. But the ministry and our companies, we have some bureaucratic blockages. And there are so many companies like ourselves that are really beneficial and great contributors to the defense industry. I would just like to ask for your help in order to make sure that we don't encounter these bureaucratic blockages. Of course, as ASFAT's working principle, it entails the military factories, military shipyards, and private sector. These are all really important for us. So the private sector in Turkey and sometimes in other countries, it is a key component in our perspective, in our principles of working. And the resources that we have here, we add them value, we evaluate them, and we can definitely help you with the bureaucratic blockages. Hi, my name is Murat Noğlu. I'm one of the IT Valley entrepreneurs. We are working on digital transformation. I will ask a question for the moderator. With the national technology move and software, we talked about it. In the defense industry, we achieved a lot, but when we go to technopart, the technologies that we manufacture in the private sector and in the public sector, we have to work with other specifications coming from other countries, and we call this a national movement. But I want to ask you what we can do to make it more national, actually. Yeah, we have some incentive mechanisms for the digital transformation in the industry. When you complete some procedures, for example, the measurements of digital maturity level, and after you get this scores for the digital maturity level, you have to prepare a 5-year plan or roadmap, what kind of things you will do for the next 5 years in terms of digital transformation. And then as a result of that, we can subsidize 50% of their investments. So this is one of the incentive programs that we have. So the basic principle behind this is that if you are taking advantage of this incentive in the investment, you should choose the national sources, and this is something that I can summarize in that way. If there is an incentive that is being contributed to your company, of course the priority should be on the national sources. So we are trying to direct that, but at the same time, the number of tools that are used for the measuring of the maturity level, digital maturity level, we are also improving that side. We will try to include the service sector as well. So the defense sector, defense industry success, we are taking it as an example, and we are going to convey it to the other areas as well. So there will be some criteria in these incentives. Yes, there will be. Okay, thank you very much. We talked about software, the national digital transformation and technology movement. I want to thank all the valuable panelists who came us, and I would like to also thank the audience for their attention. Thank you.
Değerli moderatörümüze ve panelistlere
We would like to thank all the panelists and the distinguished moderator. We will give some memorabilia for today. Now, on behalf of Saha Istanbul, we are inviting Lieutenant General Ayhan Tuna onto the stage.